List as in Python.
Lists are a fundamental data structure in Python programming. They are widely used in Python for storing collections of data, iterating over elements, and performing various operations such as sorting, filtering, and transformation. Lesson highlights: List data structure. Comparing lists. Modifying a list. Accepting elements of the list from the user.
List data structure. In Python, lists are a versatile and commonly used data structure that allow you to store and manipulate collections of items. Lists are ordered, mutable, modifiable, and can contain elements of different data types. The three characteristics of a list are given below. Ordered collection. Lists maintain the order of elements in which they are added. The order of elements in a list is determined by the sequence in which they are inserted. Mutable. Lists are mutable, meaning that you can change their elements after creation. You can modify individual elements, append elements, insert elements, remove elements, and more. Heterogeneous elements. Lists can contain elements of different data types, including integers, floats, strings, boolean, and even other lists. Elements within a single list can be of different data types. Creating a list. Lists are created by enclosing comma-separated values within square brackets. The following is an example of a list with integers. int_list equals 1, 2, 3, 4, 5. Some more examples of lists are given below. String_list equals apple, banana, mango, guava. float_list equals 3, 14, 5.23, 6.75, 9.19. char_list equals a, e, I, o, u. Mixed_list equals a, boy, 8, 23.5. Accessing elements of a list. Just like strings, the elements of a list can also be accessed using index notation. Indexing starts from 0 for the first element. Negative indices can be used to access elements from the end of the list. Consider the following statements. Print int_list 0. Output is 1. Print string_list 3. Output is guava. Print float_list 2. Output is 6.75. Print char_list 1. Output is e.
Double-click. Subject enrichment. You can use the negative indices to access elements from the end of the list. For example, print bracket mixed_list, bracket minus, 1 bracket, hashtag accessing the last element, output is 25. 5. Print bracket mixed_list, bracket minus 3 bracket, hashtag accessing third last element, output is boy.
List slicing. Lists can be sliced to extract a subset of elements using the slice notation. Start-stop step. Slicing allows you to create new lists containing a portion of the original list. Consider the following statements. Print int_list 1 to 3. Output is 2, 3. Print char_list 3 to 5. Output is O, U. Example 1. A program to demonstrate the list slicing operation. Creating a list. Food_list equals apple, banana, mango, potato, capsicum. Brinjal. Fruit_list equals food_list 0:3. Creating sublist of fruits. Vegetable_list equals food_list 3 to 6. Creating sublist of vegetables. Print fruits list is fruit_list. Print vegetables list is vegetable_list. Print, leaving a blank line. Print printing fruits list in reverse order. Print fruit_list -1, -1. Output of example 1. List operations. Lists support various operations such as concatenation, plus, repetition, asterisk, and membership testing. In Example 2, a program to demonstrate list operations. Fruit underscore list equals apple, banana, mango, vegetable underscore list equals potato, capsicum, brinjal, combined underscore list equals fruit underscore list plus vegetable underscore list. List concatenation. Print fruit list is, comma fruit underscore list. Print vegetable list is, comma vegetable underscore list. Print combined list is, comma combined underscore list. Print repeating the list. Print combined underscore list 3. List repetition. Print search underscore item equals input. Enter the name you want to search in the list. If search underscore item in combined underscore list, print the item exists in the list. Else, print the item does not exist in the list. Output of example 2. Modifying a list. Lists are mutable, meaning that you can change their elements after creation. You can modify individual elements, append elements, insert elements, remove elements, and more. Modifying individual items in the list. To modify an individual element in a list in Python, you can simply access the element using its index and then assign a new value to it. Consider the following statements. Hastagi original list, my underscore list equals 1, 2, 3, 4, 5. Hastagi modify the element at index 2, third element, to 10. My underscore list 2 equals 10. Hastagi print the modified list. Print my underscore list. Output 1, 2, 10, 4, 5. Built-in functions for lists. Python provides several built-in methods for working with lists. Some of them are described in the following table. Function. Description. Example. Append. Adds an element to the end of a list. My underscore list. Append element. Insert. Inserts an element at a specific index in a list. My underscore list dot insert index element. Remove. Removes the first occurrence of a specified value. My underscore list dot remove value. Pop. Removes an element at a specified index. My underscore list dot pop index. Extend. Adds all elements from another list to the end of the current list. My underscore list dot extend other underscore list. Sort. Sorts the elements of a list in ascending or descending order. My underscore list dot sort. My underscore list. Sort reverse equals reverse. Reverses the order of elements in a list. My underscore list dot reverse. Index. Finds the index of the first occurrence of a value in a list. Index equals my underscore list. Index value. Copy. Creates a shallow copy of a list. New underscore list equals my underscore list. Copy. Count. Counts the number of occurrences of a value in a list. My underscore list dot count value. Clear. Clears all elements of a list and returns an empty list. My underscore list dot clear. Len. Calculates the length of a list. Len my underscore list. Max. Returns the largest element in a list. Max my underscore list. Minute. Returns the smallest element in a list. Minute my underscore list. Example 3. A program to demonstrate the use of built-in functions of a list. Creating an integer list. Int underscore list equals 1, 2, 4, 5, 6. Print length of list is, comma len int underscore list. Print largest number in the list is, comma max int underscore list. Print smallest number in the list is, comma min int underscore list. Hashtag creating a string list. String underscore list equals apple, banana, orange. String underscore list dot append mango. Print string underscore list. Hashtag using built-in functions of list. Int underscore list dot insert 2, 3. Print int underscore list. int underscore list dot remove 3, print int underscore list dot pop 3, print int underscore list dot reverse, print int underscore list dot extend string underscore list, print int underscore list string underscore list dot sort, print list in ascending order, comma string underscore list dot sort reverse equals true. Print list in descending order, comma string underscore list. Print new underscore list dot clear, print new underscore list. Output of example 3.
Hands-on time. Interdisciplinary. Science. Write a program to create the following list. Internal underscore organs bracket, heart, liver, kidney, lungs. External underscore organs bracket, mouth, hands, legs, eyes, bracket. Now, perform the following steps. 1. Append stomach to the end of the first list. 2. Insert ears and nose after legs in the second list. 3. Print both the list.
Comparing lists. To compare two lists in Python, you can use the equality operator equals. This operator checks if the elements at corresponding positions in both lists are equal. Example 4. A program to compare two lists. Hashtag define two lists. List 1 equals 1, 2, 3. List 2 equals 1, 2, 3. Hashtag compare lists. If list 1 equals list 2, print the lists are equal, else, print the lists are not equal. Output of example 4. In this example, both list 1 and list 2 have the same elements in the same order. However, if the lists have different elements or are of different lengths, the equality check will return false. Consider the following example. Example 5. A program to compare two lists with different elements. Hashtag define two lists with different elements. List 1 equals 1, 2, 3. List 2 equals 1, 2, 4. Hashtag compare lists. If list 1 equals list 2, print the lists are equal, else, print the lists are not equal. Hashtag define two lists with different lengths. List 3 equals 1, 2, 3. List 4 equals 1, 2, 3, 4. Hashtag compare lists. If list 3 equals list 4, print the lists are equal, else, print the lists are not equal. Output of example 5.
Double-click subject enrichment. Keep in mind that this comparison method checks for equality of both the elements and the order of elements in the list. If you want to check if two lists contain the same elements but possibly in different orders, you may need to sort the lists first before comparing them.
Accepting elements of the list from the user. You can accept elements of a list from the user by using a loop to iterate over the desired number of inputs and appending each input to the list. Example 6. A program to accept elements of a list from the user. Hashtag initialize an empty list. My underscore list equals curly bracket. Hashtag get the number of elements from the user. N equals int input enter the number of elements. Hashtag iterate over the range of the number of elements. For I in range n. Hashtag get each element from the user and append it to the list. Element equals input enter element, I plus 1. My underscore list dot append element. Hashtag print the final list. Print the list entered by the user is my underscore list. Output of example 6.
Teachers guide. Start by explaining the concept of lists to students. Explain the syntax for creating lists and examples of different types of lists. Demonstrate how to access elements in a list using index notation. Discuss zero-based indexing and negative indexing. Provide examples of accessing individual elements and slicing lists. Introduce common list operations such as concatenation, plus, repetition, asterisk, and membership testing in Demonstrate built-in methods such as append, insert, pop, remove, and assignment. Provide a variety of problems that involve creating, modifying, and accessing elements in lists. Quick recap. Lists are ordered, mutable, modifiable, and can contain elements of different data types. Lists are created by enclosing comma-separated values within square brackets. Just like strings, the elements in a list can also be accessed using index notation. Indexing starts from 0 for the first element. Lists support various operations such as concatenation, plus, repetition, asterisk, and membership testing. In lists are mutable, meaning that you can change their elements after creation. You can modify individual elements, append elements, insert elements, remove elements, and more. To compare to lists in Python, you can use the equality operator. The knowledge vault. Creating two-dimensional list, 2D list, in Python. In Python, a 2D list is simply a list of lists. Each inner list represents a row, and each element inside the inner list is a column value. Elements are accessed using two indices, list bracket row bracket, bracket column bracket. Example code. A 2D list with 3 rows and 4 columns marks curly bracket. 85, 90, 78, 92. 88, 76, 85, 80, 90, 91, 89, 95. Bracket, bracket. Printing first row print, marks, 0. Printing first element of first row print, marks, 0. 0. Output, 85. Printing last element of last row print, marks, 2. 3. Output, 95.